Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to use electronegativities to classify bonds. And so let's get into this. So in this particular problem, we're asked which bond would you expect to be more polar? Now, you can answer this question by looking at the periodic table and using your periodic trends, right? So we know that electronegativity is going to increase going up a group or family, and it's going to increase going across a period from left to right. So we can use that to our advantage to figure out which bond is going to be more polar, especially if the bonds or the atoms we're comparing or the bonds we're comparing has a common atom that is the same. And so all we need to do is look to see what the other atom, where the other atom is on the periodic table. So let's go ahead and get into this here. So for A, we're comparing HS bond with an HCl bond. Since they both have hydrogen in common, that's going to stay the same. So the difference in electronegativity between these atoms is going to depend on the other atom, the sulfur and the chlorine. So we saw before that if you look on your periodic table, or if you have an electronegativity periodic table with the electronegativities written on it, then you can look at that. If you look at that, you'll find that hydrogen has an electronegativity. Let me use a different marker. An electronegativity of 2.20. So that's the same for both of these. And so the electronegativity difference is going to depend on the sulfur and the chlorine. Now, if you look at your periodic table, you'll see that both sulfur and chlorine are in the same period. They're right next to each other. But chlorine is farther to the right. So we know that if you go from left to right in the period, the electronegativity increases. So we would expect that chlorine would have a higher electronegativity than sulfur. So if we look at our electronegativities, we see, what do we see? Let me look up the electronegativities. And we see that, let's see. Sorry about that. Sulfur has an electronegativity of 2.58. So 2.58 for the sulfur, and for the chlorine, for the chlorine, we have 3.16. So chlorine has 3.16. So that's going to give an electronegativity difference for the H hydrogen sulfur bond. That's going to be 0.38. So if we write 0.38 for that, so the HS bond has, here, let me, so this bond here has an electronegativity difference of 0.38. The HCl here is going to have an electronegativity difference of about, let's see, 0.96. So this bond here is going to have a difference in electronegativity equal to 0.96. So we can see that this HCl bond has a greater electronegativity than the electronegativity difference between the HS atoms. So that bond is going to be less polar than this bond because there's a greater electronegativity difference between these two. So again, if we are going to apply the partial negative, partial positive, the partial negative always goes to the side that has a greater electronegativity because it's pulling on the electrons more. Electrons are negative, so the electrons are going to spend more time. More of the electron density is going to be around the more electronegative atom. So the chlorine and the sulfur would have the partial negative, and the hydrogen would have the partial positive. Okay, now what about B here? So here we got phosphorus and hydrogen bond and phosphorus fluorine bond. So again, here we have phosphorus as the common atom. So the electronegativity difference is going to depend on fluorine and hydrogen themselves. So let's look up the electronegativity of phosphorus. So phosphorus has electronegativity of 2.19. So 2.19 for the phosphorus. Hydrogen again has 2.20. So that's going to be an electronegativity difference here is equal to 0.01. So very small electronegativity difference. Fluorine has like 3.9 something. So fluorine has 3.98. So 3.98. So that's a much larger electronegativity difference. So that's going to be, let's see, 81, 79, like 1.79 about, if I calculated that correctly. Nope. That's going to be, yeah, 1.79. That is correct. Yeah. So 1.79 is the electronegativity difference. So the difference in electronegativity is equal to 1.79. And so much bigger electronegativity difference in this one. So then therefore, this is going to have a larger polarity in the bond than this one. So this is going to be much more polar than this one. And again, we would put the positive, the partial negative on the more electronegative atom. So here in this bond, fluorine would have the partial negative and phosphorus would have the partial positive. Here, this would actually be a nonpolar bond, so there is no partial positive, partial negative. It's just a nonpolar covalent bond, so no polarity in this bond at all. And that is it for this video. I hope you enjoyed this video. If this was helpful in any way, if you enjoyed it in any way, then please like the video. Hit that like button. Okay, share it with your friends. Share this video broad and wide. Also, make sure you subscribe to my channel, hit that notification bell. And when you do, make sure you click all so you'll be notified by all the videos that I put out. Also, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you would like me to go over for you, or if you have a topic you want me to cover, then please let me know. I would love to do that for you. Thanks for joining me and have a great day.